Okay, so here we go with the next example on the mechanics, still on velocity time graphs. Usual, let's pick out the key information. So particle moves along a straight line. Particle accelerates uniformly from rest to 8 meters per second in t seconds. The particle then travels at a constant velocity of 8 meters per second for 5t seconds. The particle then decelerates uniformly to rest in a further 40 seconds. Sketch a velocity time graph to illustrate the motion of the particle. Okay, so we've got a velocity time graph. Oops, let's get that. So velocity time, velocity, let's check the units, meters per second, time in seconds. It accelerates uniformly, so that's going to be a straight line from rest to a velocity of 8 meters per second in t seconds. So that's 8. And it takes t seconds to that point. So accelerates uniformly from rest, 8 meters per second to 2 t seconds has given us that bit of the graph. The particle then travels at a constant speed. So it's travelling at a constant speed of 8 meters per second for 5t. So we're going to get a section in here. And that time is 5t seconds. So we're going a total of 5t along here. So the time on the scale will be 6t. It then decelerates uniformly, so a straight line, to rest in a further 40 seconds. So this is 40 seconds here. And we get 6t plus 40 as the total time on the axes there. So this bit, particle decelerates uniformly to rest a further 40 seconds, gave us that section of the graph. And that's our velocity time graph sketched. In an exam, I would highly recommend doing all that with a ruler. Okay, given that the total displacement of the particle is 600 meters. So total displacement, as soon as you see that word displacement, we should be thinking that is the area under a velocity time graph as our key information, the factual knowledge that we need to answer the question. And we're told on this occasion it's 600 meters. Find the value of t. So, displacement. Identify the shape. Well, again, it's a trapezium, so we know it's a plus b times h over 2. So that's the a, that's the b, and that's the h, the perpendicular distance between the parallel sides. So we now substitute in a. Parallel side is 5t plus, so that was the red that we had up here. And then we're going to have this section along the bottom, which we know is 6t plus 40, 6t plus 40. And then h over 2, so h is that section there, h over 2, hang on, we don't actually want h, we want times 8, which is the height, over 2, so that's that bit. Now there's a mistake in what I've actually written. One of those things that we do when we concentrate on other things, we need brackets around that whole a plus b expression. Now we can tidy it up, collect the like terms. 11t plus 40 is equal to, times 4 is equal to, well, what were we told in the question? The displacement is 600 metres. So it's up to you. We could expand or divide by 4, whichever you prefer. I will just stick to our usual routine. So expand the bracket. 600 minus 160 is 440. Well, that couldn't be nicer. Over 40 times 44t. So t equals 440 over 44, which is 10 seconds. Okay, homework that should be attached to that bit of work. Those 3 examples are exercise 9A, questions 2, 3 and 4, and they're on displacement, time, graphs, and exercise 9B, questions 3, 5, 7 and 8. You can always do more if you really want to, on velocity, time, graphs.